Good morning, everybody. Welcome to our first session. So the very first presentation is kind of a high-tech demonstration of some very advanced technology called libRIST. And libRIST is a way that you can download all the software you need to implement a solution that is based on RIST, which stands for Reliable Internet Stream Transport. And Sergio is the primary author of our RIST library, and obviously there's been other contributors as well. But Dr. Sergio Ammirata is president and CTO of SipRadius, and he's going to be giving us a great presentation this morning. So take it away, Sergio.
Thank you very much. All right, I'll start. Good morning. My name is Sergio Ammirata. I'm the Chief Scientist of Amox LLC, the broadcast division of SipRadius. Our main products are a Linux distribution and a multimedia application suite geared for professional broadcasters. But today, I'm wearing my other hat, which is as the maintainer of libRIST. All right, so libRIST is a free and open source implementation of the RIST error correction protocol. We're going to do an introduction and demo of libRIST today. You'll learn how to obtain, compile, and use it. So first, a quick review of what an error correction protocol does. RIST is a relatively new standard. It's meant to encourage interoperability between vendors. It uses UDP versus TCP for media transport. And using UDP means we get the data faster to the destination. That's especially important for media transport. The cost for that is that we don't get message acknowledgements like the TCP protocol has. So the error correction protocol adds sequence numbers, timestamps, or other information so that the receiver can detect a missing packet. That way, it can re-request anything that's missing. Of course, there's a delay buffer to allow time to detect missing packets and re-request them. But at the end, the result is a complete media stream, error-free media stream. Okay? But let's not just look at slides. We've set up a network emulation here that will draw packets between a source device and my notebook. We'll show you the details in just a bit, but first, we'll stream a video from the device to my notebook, and that way we can establish a baseline of how the video would look without RIST. Okay, I'm going to switch now to the console that is connected, and I'm going to start the stream. And I'm going to start the receiver. We'll go in details on this later. I just want to establish the baseline. Okay. Okay. So that's our baseline of how the video looks with just 5% packet loss. Okay, so let me go back to this slide. Beyond error correction for lost packets or packets out of order or corrupted packets, let's list libRIST's more advanced features before we actually demo it in action. Number one, you can send and receive more than one stream through the RIST connection. Number two, it supports strong AES encryption. Number three, we also add on an authorization process with an HT password type hash management tool. Importantly also, you can set it up so that either side, sender or receiver, can first contact the other or initiate the connection. This makes connections where one side is behind a firewall much easier. And when you have multiple internet gateways, you can split the traffic between them, or if you prefer speed instead of redundancy, you can do bonding and load balance the different links for a higher speed or throughput. Okay, so let's tell you how the demo will work. The network emulator will drop, corrupt, and place packets out of order. Okay, let me switch to the user interface of the network emulator. Okay, that's the user interface. This is the administration page for the emulator. It's running in a small black PC, right here. I'm gonna very carefully bring it out. It's one of our products. It's just a simple device, fanless PC that is able to act like a switch and drop packets and manipulate the network. All right, let's see. We set it up initially just for 5% packet loss, like you see here on the GUI. Let me show you this number right here. It supports, we added a delay as well to simulate a real network, but we can do duplication, reordering, packet corruption, etc. So once, let me go back to this slide, hold on. Okay, once it reaches the notebook, the RIST receiver will then forward it to VLC, which will open and show you a playback of the video flawless. All right, now the physical part of the demo. We actually have two network cables going from the laptop to the black box, to the network emulator. One of them is for management, and the other one is where we're going to be receiving the data. The emulation software inside the emulator acts like an internal bridge, and we're able to configure the output characteristic through any port. That way it can do its thing, depending on the port we connected, and add latency, drop packets, corrupt packets, etc. The video source, which in this case is going to be FFmpeg, will run directly on the small black box. It outputs a UDP stream to the local host address of the black box. Then we start a RIST sender that will also be running on the small black PC. It will pick up the video at the local host and send it over the emulation port to the notebook. On the notebook, we'll start a RIST receiver, and it will detect dropped packets, re-request them, and reassemble the corrected media stream. Then it will output to the local host on the laptop, where we will pick it up and display it using VLC. We'll show a diagram of this later as well. All right, so now let's switch to the actual demo. We still have this running as a comparison, and I'll leave it running. Okay. So we have several consoles already open. Several of them are connected to the black box, and others are connected to my local laptop. So I'm going to start, we'll start inside a console that is already on the black box on the sender. Let me go there. This one in particular, okay, there's multiple tabs. The first tab is the one we started, a direct stream to my laptop without error correction. I'll leave that running, and this second tab is already connected to the black box as well. Okay. The first thing I want to do, because we'll show the authorization process in this demo, is create a password file. So the password command that's a password command. Hopefully, the text in the console is large enough for everybody to read. libRIST includes a utility called RIST SRT password. If you're familiar with Apache's HT password utility, it's something along those lines. So we're going to go ahead and generate the password now. So we've generated our user and password, and let's just show you the hash. Okay, so I'm going to go ahead and run a command to show you that file that was just created, the temp SRP pass. Okay. As you can see, we store a nice SHA-256 password hash there. It should look familiar to anyone who has ever used Apache SSD password. And of course, you can keep adding lines and multiple users to this authentication file, just like you do with a regular web server. So let's start now. Let's go ahead and start the original video source, which is a file on a loop, but this time we'll direct it on a port on the local adapter inside the PC itself. Okay. So that's the command line. FFmpeg just starts the file and outputs it to the local adapter on the black box. And there it is, just a streaming of the file to the local adapter of the emulator machine. So the libRIST sender will use this stream as the source. So let me paste the command or show you the command for the RIST sender before I run it. All right. So that's the command line. I'm not going to run it yet. But what we're going to do is invoke the RIST sender, and let me explain the command line parameters of the tool. So the -i parameter is the input command. We have directed the video to the local host, so we have it here, reading the input as UDP, a standard transport stream from the local host address and port 8192. Next, we give it an ID. Because libRIST supports multiplexing, adding multiple streams, we can repeat this -i multiple times and have streams with different ID multiplex so that we can, the other side, separate them. Here, I'm only going to demo one. Then the -o parameter is the output. In this case, we have one peer. But we can have up to 10 peer destinations or RIST receivers. On the emulation, we have added a 35 millisecond latency, which would be equal about a link from New York to LA. So we've tuned some of the parameters on our command line accordingly. For example, we have boundaries for the minimum and maximum round trip times, so that when the protocol adjusts, does it within sub-reasonable boundaries. This is the RTT min and RTT max. We've set it up from 35 to 105. This gives purpose because we don't want to flood the network with re-request messages by having those parameters perhaps go out of whack or outside some boundaries that are reasonable. The library will measure the round trip time automatically and readjust, but that automatic measurement has a boundary that we can set up here. So continuing with the -o parameters, you may see the @ in front of the 172. This means that we have set up the sender to listen on a port instead of initiating the connection. The receiver will listen for the RIST peer to connect to it. With the authorization password file in place, then the sender that connects, the receiver that connects to this port will have to authenticate in order to receive the stream. All right. So each user that connects can have a separate username and password to follow sort of like a multimedia or a media server model where you have one source and you can have many clients trying to connect to receive the stream, each of them with an independent password. So in effect, we set up many to one to RIST standard for a lot of users. libRIST is not very intensive when it comes to CPU usage, so you're probably going to run into limits of bandwidth before you run out of CPU. So I'm going to go ahead and start the sender now. All right. So now we're going to turn on the receiver, which is directly on my notebook. So this is directly here. So run receiver here. That's the command line for the receiver. Let's explain the command line. The input parameter matches -I, but this time the input for the receiver is the RIST on the other side. So we're going to initiate the connection. That's why we don't have the @ in front of the 1. This is going to connect to the IP on the other side that's listening. We don't reference a password file because the receiver doesn't use a password file. The username and password is part of the command line, and it's a single one. The other side has the multi-user, but the receiver is just a single password, and that's why we have only one of them there. The passwords are sent using the SRP protocol, very secure, so it's never exchanged or sent on the clear. This authentication process provides an extra level of security, and that's of course on top of the already encrypted AES tunnel that is formed. So our output in this case, -O, is directed to the local adapter on the laptop at port 8192. So let's go ahead and start the receiver now. And you can see that it's already spitting out the stats 1 per second about the transmission, the bit rate. There's a ton of very valuable stats in there. So now that we have the tunnel established, let's start VLC and let's go ahead and play it. This is another tab on my local laptop. So I'm going to, let's see, receiver. If you can see here, the script is I'm just starting VLC, reading from the local adapter. That's all it is. And here's the video after going through RIST. And as a reference, let me show you, I still have the other one running that goes direct. Let me reduce the size. So, all right. So there you have it, with and without RIST, with 5% packet loss. Same source, same file, same network. All right. Of course, we can play with additional parameters, and to show you that this is no smoke and mirrors, I'll go ahead and grab our emulator user interface, which shows right now the packet loss, and I'll tell it, you know what, let's give the direct playback a break. Let's do no packet loss. And there you go. So now the direct video plays perfectly as well. It's you notice that there's a delay, because the RIST one is 1 second behind, which is a buffer we've allocated for packet recovery. The buffer can be a lot smaller because we only have 35 seconds of latency, so 5 times that, we could set a 100 millisecond, and that would be 5 to 6 times. So let me go ahead and put again packet loss here. Let's go all the way to 15%. And there you go. Unusable video and video without any packet loss whatsoever. All right. Let's go to the next. All right, let's go back to the presentation. Bear with me for a second. Okay. I can find it. Too many tabs open. All right, let's switch to the next one. So here's a diagram of what's happening in the demo to make it more, a little bit clearer. We have on the upper left-hand side FFmpeg on the black box. We call this a sender. Outputs a UDP stream from a file directly to the local adapter. Then we started on the next box is we grab the RIST sender command line utility from libRIST, and we initialized the link, and we listened on a port for somebody to connect. Then we come down here. This is in a laptop, the RIST receiver. We started, and we tell it to connect to the RIST sender on the black box with authorization and encryption. The receiver then establishes a tunnel, starts receiving the data with the information that it's required, and it sees a lot of packet loss, and it requests the packets, and they come back, and fills in the gaps in the buffer, and outputs, with a latency equal to the buffer, the perfect video on this side. And here we describe the process of, analyzing the buffer, asking for the re-requests, and then filling the gaps in the buffer. That's these three steps here. Finally, once the buffer expires for every packet, hopefully we've recovered all the data by then, we output to the local adapter, and we have VLC playing out that video right there. So again, just to bring the point very clear, this is what this buys you. It adds complexity, but it allows you to use a lossy network such as the internet to transmit your video flawlessly. Okay. So let's go over briefly of what you need if you want to compile libRIST yourself. These instructions are for Linux. There's plenty of documentation for Windows and Mac OS, etc. But the dependencies are just standard packages that are available on any distro, just standard stuff. Once you install the dependencies for compilation, you go ahead and you clone the repository. The repository is hosted on VideoLAN. So this is a command. I'm not going to do it here because I don't have internet. I already cloned it. I can show the compilation as well. You clone the repository, and then that creates a folder. You enter the folder, and then you follow this step. This is also very well documented in our wiki online. You create a folder. You go into the folder. You run this command, and that basically configures the package. You run Ninja to compile it, and you're done. Then you install it on your laptop, and then now you have the command line utilities and the library installed on your setup. These same command line utilities are available for Windows and for Mac OS. And you can compile them from scratch, with a set of instructions that we have online. Let's go to the next one. So like I was saying, once you're done with the installation, you have the library, you have the binaries. Now the binaries, we consider them example applications, but at the same time, they're production quality tools. Inside our OS, for our commercial products, we use the same command lines as is. So you'll have access to this presentation. I'm not going to go over. I put them here so you have it as a reference when you're looking at the presentation offline. And in conclusion, you have a free and open source project you can use with a very liberal license. You can use it for commercial purposes without worrying about having to contribute back. Of course, we'd love if you contribute back, but you don't have to. You don't even have to guess gravity. You can just put it in your product. Thank you very much.